This is problem number 13 in the Chapter 3 quiz, which is quiz 2. It gives us a balanced equation with letters instead of chemicals. It tells us the actual yield. I actually make 0.3 moles of D. This is the actual yield in the lab. And I start with these two. So this asks me to find the percent yield. But the other interesting part of this problem is it's a limiting reactant problem because I have reactant A and reactant B, and I have to figure out which one limits the reaction. So the first part I'm going to do is for the limiting reactant. And to find the limiting reactant, I want to figure out which one makes the least amount of D, because when that happens, it will be used up. And I might have extra of the other one, but I won't be able to make any more D after the smallest one is used up. But I can't just assume it's 2.5 because that's the smallest number. But it takes 5 B's and 3 A's, so it's not equal. So it's actually something I have to figure out. So if I have 6 moles of A and I have 2.5 moles of B, and I want to convert each one to moles of D. And because this is just mole to mole, it's a 2-column T-chart. If this problem was working in grams, you would have to do grams to grams, which would be a 4-column T-chart. So drop down my units, and what you notice is I have moles to moles. That comes from the balanced equation. So there's a 3 in front of the A and a 1 in front of the D. A 5 in front of the B and a 1 in front of the D. So when I do this out, I get 2 moles of D. Well, 2.5 divided by 5 is 1/2, so that would be 0.5 moles of D. So what this is saying is, if I look at how much B I have, I could make at most 0.5 moles of D if I totally ignore how much A I'm mixing. If I do the reverse, totally ignore how much B I'm mixing and look at my 6 moles of A, I can make up to 2 moles of D. So the one that makes the smallest amount of D is the limiting reactant. So here's the smallest amount of D, but that means B is my limiting reactant, which means that I actually can only make 0.5 moles of D. This is my theoretical value. It's my theoretical yield. Theoretical meaning if you do the math, what would you get? So percent yield is the actual, what you get in the lab, divided by the theoretical, times 100 to make it a percent. So in this case, it's 0.3 divided by 0.5 times 100. So 3/5, if I think about that, would be 0.6, so 60% yield. Now if I look at this, my actual yield was measured in moles of D. My theoretical yield then has to be measured in moles of D. I can't just do 0.3 divided by my 6 moles of A or my 2.5 moles of B. The key here is it's the actual of some amount divided by the theoretical of that same amount so that the units cancel and I can get a percent yield.